Over the next few videos, we will do a deep dive into the world of MMM. In this video, we will start with an introduction to MMM and its many philosophies. We'll do a high-level overview of the MMM approach in an extremely simplified form. The idea here is to help you build the right intuition about MMM before we even get into the actual mechanism that runs under the hood. In the next video, we will jump right into Causal MMM. And at this point, it will help to briefly revisit our third video of the series, which was about causality and how to think about its connection to correlation. After this, we will dive into Lifesight's approach to MMM and also have a detailed demo of Lifesight's models module, which is where we enable marketers and marketing scientists to define the business DAG, upload or sync the data from various apps and data warehouses, and run fully configurable, transparent, and semi-guided marketing mix models. After this, we will spend some time discussing the life cycle of MMM models through the stages of model training, backtesting, model calibration, model drifts, retraining, sunsetting, and so on. We will also discuss the shortcomings of MMM as a standalone measurement method, the importance of knowing every assumption that's incorporated into the model and the modeling process, and how marketers should complement MMM with experiments and also with attribution in certain cases such as measuring affiliate marketing for better results. We will also touch upon how Lifesight ensures that we generate the best models possible given the data. Some of these recommendations could be adopted by your team, even if you choose to build MMM in-house using any of the open source libraries such as Robin, PyMC, Meridian, or Orbit. Now, let us start with an introduction to MMM. But before that, a small disclaimer. When we say MMM, we specifically mean marketing mix models and not media mix models. We believe that the true power of MMM as a causal tool for planning and forecasting could be realized only if we include all the major business factors into the model. We need to capture the right mediators, confounders, and possibly the colliders in the data. This is not always straightforward, but let us not jump ahead of ourselves and let us take this one step at a time. This is where it begins. In the year 1964, yes, 60 years back, Neil Borden published an article called The Concept of Marketing Mix. In the abstract of this article, it reads like this. Marketing is still an art. The marketing manager, as the head chef, must creatively marshal all his marketing activities, not just media activities, to advance the short and long-term interests of his firm. This article is believed to have started the storied history of marketing mix modeling. It was the go-to measurement technique for decades, until the internet age kicked in, and major internet media companies force-shifted measurement narratives to click-based user journeys. And the meaning of the word attribution changed forever in the marketing ecosystem to mean user journey-based credit distribution. Everyone bought into this as it sounded more data-driven. User-level journey meant more data and was interpreted as better decision enabler. For the last couple of decades, marketing analytics focused primarily on collecting more and as much user-level data across all the touchpoints as possible. This led to a series of transgressions on customer privacy. The emerging privacy-focused technologies and regulatory policies started to come in the way of this process, making user-level data collection infeasible. This disrupted the new age status quo wisdom of what it means to have good measurements. Now, most of the marketers are going back to the age-old wisdom of Neil Borden and marketing mix modeling and practices such as randomized control trials, which was first run in 1774 to find cure for scurvy. Essentially, marketers are now upgrading themselves to think in terms of probabilistic interpretation of aggregated, privacy-safe data. The new schools of thought in modern measurements even refutes the assumption that having user-level ad exposure data is in any way meaningful in making any marketing optimization decisions. Remember the example of eBay that we discussed previously. They had accurate and perfect user journey available, but until they could quantify incrementality, they couldn't cut down on their ad spend waste. So all the technical, regulatory, identifier challenges aside, even the availability of user-level data cannot equip you with the right budget optimization planning unless you switch to an incrementality system. MMM is the most scalable incrementality measurement technique that's available today. You can get your first read of incrementality across all your paid, owned, earned media spend, and also can understand incrementality offered by other relevant factors such as product, promotion, seasonality, brand equity, or loyalty, and so on. You could even run MMM models across dimensions such as geography and device type, helping you make the inferences across different levels of data segregation. These incrementality numbers from MMM should be understood from within a confidence interval or credible interval in case of Bayesian modeling. Variables with lower observations and higher confidence interval should then be recommended for incrementality testing. Every assumption baked into the model should be scrutinized and must be compared against the business wisdom of the marketer. In MMM, we look at the data at an aggregated level. What you see here is a sample schema of MMM data. This is tabular and temporal. Here we have daily or weekly observations of a bunch of input variables called covariates or independent variables, and one output variable called target variable or dependent variable. So regression-based MMM is the approach of fitting a line, actually a hyperplane, on this multidimensional data in such a way that it minimizes the error between the actual and modeled value of target variable and get the best fit on the given data. But when it comes to MMM, it's not that simple. Nothing is simple when it comes to marketing or marketing measurements. How is MMM different from a regular regression model? It's different in these three important ways. Point number one, the impact of covariates on the target variable needs to be understood from the perspective of a time varying effect, either a time-based lag or a time-based decay. That is, your investment in TV today will create some immediate impact for your business and also some long-term recall of your brand, leading to some long-term impact as well. The spike in your branded search spend might just give you immediate returns and nothing much with a long-term lag. MMM tries to incorporate these time shifts into the model. Point number two, impact of the covariates on the target variable is not always linear and also generally experiences a decrease in marginal utility. That is, it tends to saturate over a period of time. This needs to be modeled for by applying proper saturation transformation. Point number three, MMM data is also temporal. There are seasonal and trend components that impact your target variable besides the covariates that you have added into the model. So how do we address all of these nuances in the regression approach to MMM? Let us first talk about transformations, Adstock and saturation transformations. Lifesight's approach to MMM is to first transform input variables for Adstock and then for saturation. That is, we apply saturation transformation on the Adstock variables. However, generally in MMM, you could apply transformations in any order that you want. We apply either geometric decay or Weibull PDF transformation for Adstock. It helps if the marketer have some broader understanding of what's realistic transformation for any given variable. Is it immediate, short decay, long decay, short-term lag, or long-term effect? Remember in the video on causality, we discussed being aware of the assumptions. MMM incorporates a bunch of implicit and explicit assumptions. Make sure that you're privy to all of that. The equation that you see on the screen is for Weibull PDF distribution. Here K is the shape parameter and lambda is the scale parameter. Applying different ranges for these values will help us to model for different transformations of input variables. It is important to note that geometric decay is a special case of Weibull PDF. So if we have incorporated the right hyperparameter ranges, we recommend Weibull PDF over geometric decay. On the Adstock variables, we apply S-curve or C-curve to model for saturation. The industry preferred function for this is the Hill function. What you see below is the Hill function. Here alpha and gamma are the hyperparameters. An example of saturation shape with linear, optimal, and saturating periods are shown in this image here. It's important for us to decide which curve captures the business reality better. Every new channel typically goes through an S-curve, but more established and mature channels follow a C-curve. While building the MMM model, the marketing scientist only has visibility to the last 2 or 3 years of data. Hence, they should have a word with the business expert to incorporate the right shape of saturation curve. These two transformation processes that we discussed, that's Adstock and saturation, are run over tens of thousands of iterations by randomly picking various hyperparameter values from within a hyperparameter range set for every variable as part of model configuration. Though this process is fundamentally random, we will give the model some guidance in terms of how it should go about picking the hyperparameters. The model is expected to pick the hyperparameter so as to minimize certain measures of accuracy. This can either be 1, mean absolute percentage error, or 2, decomposed RSSD, which essentially refers to the distance between share of spend and share of revenue, or 3, both MAPE and decomposed RSSD. It's important to put in a word about the fourth model of hyperparameter guidance system at this point here. It's called model calibration. Model calibration is an additional guidance system for model hyperparameter optimization. If we have an accurate measure of incrementality from a system that we trust more, say geo experiments, we can use this to calibrate MMM models, essentially bringing some causal awareness to the model building process. That is, we can try to minimize the distance between model predicted revenue and the actual incremental revenue for the period of testing. Once we generate these tens of thousands of model versions by applying different transformations randomly or with guidance, and once we can ensure that the model has converged, that's all the possible best solutions are available within the iterations that we have run. In case of models that didn't converge, we could perhaps increase the iterations and run it for longer. Convergence is the process of making sure that all the possible optimum models based on what we were trying to optimize for is present within the many model versions that we have generated. In each of the model versions that we have generated above, we have also applied a regression model. Lifesight applies ridge regression as it could regularize and solve for overfitting. Now let's summarize whatever we have been explaining so far. MMM takes aggregated data, passes it through thousands of simulations of Adstock and saturation transformations, applies regression on each of these transformations, generate the model, and let us pick the best model based on certain criteria of goodness of it. Now this was a simplified explanation of what MMM does and how it goes about the problem of measurement. Next, we will discuss advanced modeling and Causal MMM.